Okay, so we are finding the LCD or the LCM. I'm going to use those terms interchangeably of rational expressions. Let's start with an example from the worksheet that I've given you, number 5. If you look at number 5, we've got two fractions or rational expressions, 9 over x squared plus 4x and 7 over x squared plus 4x minus 12. Now, the directions on this worksheet are to find the least common denominator of the given expressions. So if all I'm doing is finding the least common denominator, do I even care what my numerators are? Not at all. We only care about the denominator. So we're just finding the LCD. That's it. Now, before I can find my LCD of rational expressions, I have got to factor whatever I am given if it can be factored. Both of these denominators can be factored, so that's what I'm going to do. Alright, so in this first denominator, always check for a GCF. Is there a GCF? Yes. X is the GCF. So once I factor out the GCF, what's left is, correct, x plus 4. So that's the factored form of that first denominator. So now we need to go to the second denominator and factor it. We have a perfect, not a perfect square, but a quadratic trinomial. So we're going to break it up into two sets of parentheses. You're going to have x and x, of course, plus and minus, since the last sign is negative. And then I want the factors of 12, negative 12, that combine to give me a positive 4. 2 and 6. So I'm going to have a positive 6 and negative 2. So now it's factored. Now, to find my least common denominator, I take a look at each individual factor from both denominators. First, I see I have an x here. There's no x over here. But the rule is you take the x down because the x, that one x is the highest occurrence of x. So you have to write it one time. All right, x plus 4. There's not an x plus 4 over here, but I bring it down because it appears. If it's present, you have to include it. The same things for x plus 6 and x minus 2. They only occur one time, but that one time is enough for us to have to write it down. So our LCD is long. It's got 4 factors, but that's it. All of that is the LCD. Now, we did not have to, it didn't ask us to add these two fractions or subtract them. All it wanted us to do was write the least common denominator. That's it. So what's your question?
When we got like the x plus 4 and x minus 4, is that when we had to cancel out and you don't write it down?
Well, in the example that we saw earlier, the lady was canceling them as she used it. In other words, if she saw it one time, she wrote it down and just got rid of it so she didn't use it again when she didn't need to. Okay? All right, so I saw some confused looks. Any questions about this? Because all we're doing is we're looking at each individual factor. If it appears, then you write it down again in your LCD. If it appears the same number of times in both places, you only write it down one time. If it's one time here and one time here, then you write it down one time. If it's 2 times here and 1 time here, then you write it down 2 times because you want the highest occurrence of that factor. Okay? Let's do another one from your worksheet. All right, let's do number 8. All right, number 8. I'm just going to write down the denominators because that's really all that matters. You've got it. You got the whole thing on your page. So w squared minus 4w plus 4, and then w minus 2. So the first thing we need to do is factor. Okay? So when we factor, we're going to break this first one into 2 sets of parentheses. You're going to have an x minus and an x minus. What are the factors of 4 that combine to give you 4? 2 and 2, right? All right. Over here, w minus 2 can't be factored. That is what it is. So what is the greatest? All I have are w minus 2's. So what is the greatest occurrence of W minus 2? Twice, right? It happens twice here and once over here. So how many times do I have to write it down? 2 times. You write it down, the greatest occurrence, whatever the greatest occurrence is in either denominator, that's what you write it. That's how many times you write it down. Now, I could also write this as W minus 2 squared, and that'd be the same thing. It's just shorthand. Okay?
So we can't write it 2 squared?
Yep. Alright, so I'm gonna pause this, and I'm gonna let you work on the rest of this worksheet. Alright, so we've done a few of these. Let's do a few more. Alright, when we are doing these types of problems, we need to make sure that we understand that if it's a monomial, 2 monomials, we're going to find the LCM of the 2 numerical parts. So the LCM of 3 and 4 is 12. Let me increase my screen size real quick.
I can't even see it. I have to squint.
Alright, so the LCD of 3 and 4 is 12. The LCD of x squared and x to the 5th is x to the 5th. So overall, our LCD is 12x to the 5th. Alright, number 2. LCD of 3 and 9 is 9. LCD of x squared and y cubed, x squared y cubed. It really doesn't matter what comes first there. Alright, number 3. The nice thing about number 3 is that these denominators don't need to be factored. So our LCD is simply x plus 3, x minus 5. That's it. Alright, I think we already did number 4. No, we didn't do number 4. So we're going to factor. We get x plus 1, x plus 1. And then over here, x plus 1 and what?
X minus 1.
Okay. Now, what you're going to do is list the greatest occurrence of each factor. So x plus 1 occurs twice here and once over here. So we're going to write x plus 1 squared. And we don't want to leave out x minus 1. Okay? Okay, we did 5 together. Let's do number 6. On number 6, again, we're going to factor x plus 5, x minus 5, the difference of 2 squares. And over here, x plus 5, x plus 5. So we see that there is an x plus 5 one time on the left and twice on the right. So we're going to list it twice because we want to list the greatest occurrence. So x plus 5 squared and then x minus 5. Okay? Very basic. Very simple. Yes, sir?
So the letter ain't do it like that.
Other way around, x minus 5 times x plus 5 squared? That's fine.
Same thing.
Did the other
Yep.
letter do it like that?
She did it like this. Yep.
I forgot you could do the square.
Yeah, I didn't do the
I just
square.
wrote
Well, you can write it all out. That's fine. You don't have to do the squared.
Okay.
It's just faster.
It is a little faster. All right, these other problems are similar. Let me go down to number 10. Okay, we're going to factor this difference of 2 squares into a plus 3, a minus 3. And notice there's a GCF here. So a times a minus 2. So notice that there are no shared factors, if you will, or no like factors. So we just write them all down. A minus 2, a plus 3, a minus 3. Write them all down. That's your LCD. Okay? All right, we're going to stop that, and we're going to move on to the next aspect of this, and that is to not only find the LCD, but also add like fractions. Okay? So write this down, or add fractions with unlike denominators. So we're going to be adding and subtracting rational expressions with unlike denominators. Okay? Now, we're going to use the worksheet that we just discussed where we found the least common denominators, and we're going to actually add or subtract these fractions. So we're going to start with number 1 from this worksheet. Number 1 was 1 over 3x squared. And I'm going to add. So we're going to say plus 3 over 4x to the 5th. All right, now, we already found the LCD. That's one of the most difficult parts. No, not on number 1. LCD was 12x to the 5th. So I'm going to rewrite my new denominator. So I've got 2 fractions, so I'm going to have 12x to the 5th twice. Now, to find the new numerators, I have to ask myself, what did I multiply in order to get my LCD? So what did I multiply by 3x squared to get 12x to the 5th?
4x cubed.
4x cubed. Very good. So we're going to multiply numerator and denominator by 4x cubed to get our equivalent fraction. So 1 times 4x cubed is 4x cubed. Okay? Now, in the second fraction, what did I have to multiply by 4x to the 5th to get 12x to the 5th? Just 3, right?
Yeah.
So 3 times 3 is 9. So the final step, well, sometimes it's the final step. In this case, it is the final step, is to just combine your numerators. Now, are these like terms? Is 4x cubed and 9, are they like terms? No, you can't combine them together and get a new expression and get a simplified expression. You just write it as a sum. So your final answer is going to be 4x cubed plus 9 all over 12x to the 5th.
That's it. There you go.
On that one.
You can't simplify 12 and 9.
No, because that 9 is part of 4x cubed plus 9. See, these need to go together before you can simplify. Now, if the numerator could be factored, then we would try to factor it and then cancel common factors if there were common factors, but there are not. 4 and 9 don't have a GCF. There's not an X in both places. So this is it. This is as far as you can go. Now, if I were to ask you what the restrictions on the denominator were, you would say that X is not equal to what? Not allowed to be equal to what?
Negative 12.
Nope.
0.
0. The only value that makes X equal to 0 is 0. So that plugging in a 0 for X would make that denominator 0, and that's not allowed. You can't have a 0 denominator. So X cannot be equal to 0 if you were asked for restrictions. All right, let's do number 3. Okay, number 3. 4 minus y over x plus 3. I'm going to add again. Plus y minus 8 over x minus 5. Okay, we already found the LCD. We know what it is. It was x plus 3 times x minus 5. Okay, so I'm going to rewrite that LCD as my new denominator. X plus 3, x minus 5. X plus 3. Okay, so I rewrite my LCD as my new denominator, because that's what it is. And then we ask ourselves, what did we multiply by x plus 3 to get x plus 3 times x plus 5? X minus 5. What was not here? What's not here that is here? X minus 5. So we're going to multiply top and bottom by x minus 5. Oops. Okay. Now, that means I've got to FOIL the top. So 4 times x is 4x. 4 times negative 5 is negative 20. Negative y times x is negative xy. Negative y times negative 5 is positive 5y. Okay, so you got the 4 terms there. Now we're going to do a similar thing in the second fraction. What are we going to multiply the second fraction by?
3.
X plus 3 top and bottom. Okay, now again, don't do anything to your denominator. Just FOIL your numerator. Y times x is xy. Y times 3 is 3y. Negative 8 times x is negative 8x. And negative 8 times 3 is negative 24. Alright, so I've got these terms here that need to be combined if possible. I want to combine like terms. Now understand, your denominator does not change. It's the same as it was. But I need only one fraction now because I'm going to combine the numerators. So I got a 4x and a negative 8x. What does that give me?
4x.
Negative 4x. Alright, so the x's are gone. I got a negative 20 and a negative 24. What does that give me?
44.
Negative 44. Alright. I've got a negative xy and a positive xy.
Cancel.
Cancel out. They're just gone. And I've got a 5y and a 3y.
8.
8y. Alright, now, none of these can be combined with each other because they're all different. They're not like terms. But, is there a GCF?
Yes, it is.
We can factor out a GCF. And what is that GCF? 4. So I'm going to factor out the GCF. I'm going to factor out a negative 4 so it just looks a little better. So I factor out the negative 4. That leaves x plus 11 minus 2y. All over x plus 3 times x minus 5. So you always factor it. Once you've combined the like terms in that numerator, you always ask yourself, can it be factored? If it can be factored, you factor it. Now, none of those factors will cancel out. Nothing cancels. But it still needs to be in factor form. And if I were to ask you what the denominator x values could not be, what would you tell me?
0.
Nope.
Negative 3 and negative
There
5.
you go. Negative 3 and positive 5 are not allowed because they make zeros. You're not allowed to have 0 in the denominator. Okay, questions about this? Alright, I'm going to pause the video here. I'm going to give you another handout. Now, this other handout, okay, we're going to do one more. And it's going to be, well, number 5. Let's do number 6 because I want to. All right, let's take a look at number 6. All right, so you've got your LCD. Let me write down the factored form of these things. So in the factored form, the first fraction is x plus 5 times x minus 5. And I want to make this a subtraction problem. So we're going to subtract xy over x plus 5 times x plus 5. Now, the LCD that we found earlier was x plus 5 squared times x minus 5. So I'm going to rewrite my new denominator. X plus 5 squared times x minus 5. And then x plus 5 squared times x minus 5. Now, it's ugly. It looks kind of ugly, but it's not hard. I need to know what is missing from this first part, first denominator, that's in my LCD. What's missing? Compared to these two expressions, what's missing?
X plus 5.
All right, the x plus 5 is what's missing. So I need to multiply this first fraction by x plus 5 top and bottom. All right, I know I've already done it in the denominator. I just really need to show it in the numerator. So when I do that, 5 times x plus 5 comes out to be 5x plus 25. All right, now I'm going to do a similar thing over in the second denominator. So what's missing? X minus 5. Okay, so distribute. So y times x is x squared y minus 5xy. All right, now, is there anything I can combine in order to make a different, are there any like terms in the numerator? Are there any like terms here?
Can you do 5x or not?
There's no like terms. Nothing.
Oh.
This is an x, this is an xy. This is an x squared y, this is 25. There's nothing that can be combined. But we do need, when we write this out, we do need to make sure we change our signs. Because I've got a minus here. So that means this is going to be plus, minus, plus. So I'm going to write it from the highest degree down. So it's going to be negative x squared y. And then plus 5xy plus 5x plus 25. All of that is over x plus 5 squared times x minus 5. Now, that's ugly, but it can't be simplified. There's not a common factor in all these. You say, what about 5? Well, there's not a 5 over here. You say, what about x? There's not an x over here. So you can't factor anything out. There's no GCF, and it won't factor otherwise. I mean, you might be able to use factor by grouping to factor this thing, possibly. Let me just see if factor by grouping works. All right, so let's try factor by grouping. So if I'm going to factor by grouping, I'm going to group these first two together. So I'm going to factor out a negative x squared, no, a negative xy. So when I factor out negative xy, what's left is an x minus 5. That's what's left. All right? Okay, then here I'm going to factor out a 5, and that leaves x plus 5. But when I do factor by grouping, these things have to be the same. Are they the same?
But don't work.
No, they're not. Okay? So therefore, if they're not the same, then factor by grouping is not going to work nicely on this. Maybe I could rearrange it. Maybe I could do some other things. But I'm not really worried about that. I want it to be like this. Okay? There will be other problems where it does factor much more clearly than this. All right, so I am going to pause it here, and I'm going to give you another handout.